Yes, sir.
Awesome.
Your screen is visible.
Thank you. Thanks for confirming. Just a second. Okay, so let's come now. Fine, everyone. So yesterday we discussed on detail what is logistic regression, how it works. Okay, and we also saw how it does the multi-class classification, right? One versus rest, one versus all. But actually, I want to share you some experience with me. I gave you an NPTEL examination for the deep learning. In that, actually, one question was asked from me. Okay, so I want to tell you that because in an interview you may be asked the same question, because I've seen that question several times, even on the internet it is mentioned. Like, what was the question? Something like this. Okay, so we have two variables given, x1 and x2. Okay, and suppose some data points are given like this. This is 1, this is, let's say, -1. Okay, and your points are something like this. Here also 1, here also 1. Okay, here also we have some data points. Okay, and here we also have data points, something like this, suppose. But this belong to a different class, and these outer circles belong to a different class that you are seeing right now, right? So question was given to me. This is one of the questions that was given. Okay, and second question that was given to me like this. It was like this: x1, x2 plus 3, something like this. We have some data points here. Okay, and some data points here. Okay, and question was asked. Okay, this particular data point belong to class 1. This data point belong to class 2. Okay, tell me what will be the decision boundary. Okay, or the boundary which can separate my both the classes, that is known as decision boundary. Okay, the boundary which can separate our uh, different classes. Okay, so we have two classes. So our logistic regression works for the binary classification. So they just ask me, tell me what will be the equation of decision boundary which can separate this class, this together. Okay, so what is the normal way in our linear regression? We have two variables, x1 and x2. So we mentioned this way: theta naught plus theta 1 x1 plus theta 2 x2. Okay, and remember when we discussed yesterday logistic regression, what was the case? We bring theta naught here. Okay, sorry, 1 here, then theta x1 here, then x2 here, and then we make here theta naught, then we make here theta 1, we make here theta 2. Okay, passed that to an adder, and the equation came around to be theta naught plus theta 1 x1 plus theta 2 x2. Okay, then we pass it to the logistic function or your sigmoid function. Okay, and that sigmoid function was giving me the probability, and from that we were getting a curve like this: 1 and 0, something like this. Okay, and here was your x. In our case, that x was this equation: theta naught plus theta 1 x plus theta 2 x2. So how do we classify? We know that our logistic regression always gives the probability of default class, right? And the probability, we will say that it will belong to the class default class when your y hat, or the probability that it is giving, is greater than or equal to 0.5. Okay, and we can come across this will come only when this particular reason is happening. It is 0.5 point, it is 1 point. So this condition will occur only and only when this x will be positive, or this value is greater than or equal to 0. So boundary will be what? Your boundary will be decided by this equation: theta naught plus theta 1 x1 plus theta 2 x2 equals to 0. I'm talking about the boundary, right? This is the boundary. So now what will be the decision boundary of the same? Means how will we decide? We need some equation. This is equation. This should be, from this we can say we can separate them by a straight line that I mentioned here. But what will be the equation of this? Okay, so how can I come across? See, we have to choose smartly the value of theta naught, theta 1 and x2. Everything will be done. Okay, we have to smartly choose. Suppose this is 3 and this is also 3, 0, 1 and 2, something like this, right? So what should I mention? Suppose I mention here 3. Example, everyone. Just see everyone and tell me what should I write. I mention here -3. Theta naught value I picked -3. Theta 1 value I picked to be 1. Theta 2 value I picked to be 1. Okay. So what equation I will get, everyone? I will get the equation x1 plus x2 equals to 3. Okay. But I have to write the equation in terms of y is equal to mx plus c. So what this equation will become? This equation will effectively become minus of x1 plus 3. Right or wrong? Right. Very good. Minus x1 plus 3. So it is my y-axis. It is my axis. How will I plot it? Intercept is what? 3. So I come here and come at the 3 point only. Right. Now what is the slope, everyone? Slope is -1. Right or wrong? Slope is what? -1 if we compare. So how will the equation line go? Line will go simply like this. The slope will be negative. With what? With every point of this means if it is coming by 1, it will come here. If at 2, it will come here. At 3, it will come to 0. So this will be my equation of this will be my what? Equation of decision boundary. What is that? X2 is equal to nothing but minus x1 plus 3, or you can call something whatever you mentioned here. This equation x1 plus x2 minus 3 is equal to 0 is my decision boundary. Okay, everyone, tell me first of all this, then I'll move back if it is fine.
Yes, sir. Fine.
Right. Now, can you tell me what will be the decision boundary for the same? This equation.
Sir, it will not be a line.
Yes, it cannot be a line, right? So it could not be achieved by this method. It cannot be achieved. My process should be here. Okay, now we are a machine learning engineers, right? Or we are engineers, so we should think about, okay, this cannot be achieved by theta naught plus theta 1x plus theta 2x. So what I have to do? I have to introduce higher higher degree polynomials. Then my problem will be solved. So instead of taking only theta 1 and theta 2, we should take polynomial terms as well. So if I take the polynomial terms, yes, something like this. Yes, Varun. Okay, then my equation should be like this. Let me remove this. Just a second. Come on. Yeah. Okay, if I come here, okay, and instead of taking this, I should take this. Theta naught is fine, theta 1 x1 is fine, theta 2 x2 is fine. Let me take higher order polynomials as well. Sorry, higher order polynomials as well. So I mention theta 3 x1 square plus theta 4 x2 square. So I introduce higher degree polynomials. Can you see, everyone? And the moment I introduce higher degree polynomials by using polynomial features, remember we did solve the problem with the help of polynomial features yesterday. Can you recall that? Right?
Yes,
So
sir.
we introduce higher degree polynomials. So what is the advantage of this? See, now choose smartly. Suppose I pick theta naught to be -1, theta 1 to be 0, theta 2 to be 0, theta 3 to be 1, and theta 4 to be 1. Okay. Although this will be picked by a machine learning model automatically, but what the question asks, what will be the decision boundary for the same equation? Okay, so what will we choose and understand, everyone? If we put theta 1 0, theta 2 0, theta 3 1, theta 4 1, what equation I will get? I will get -1 plus x1 square plus x2 square. And if we mixture this will become x1 square plus x2 square equals to 1 only. And this can be written as 1 square also. 1 and 1 square are both are the same thing, everyone. Right or wrong? Right?
Right, sir.
So what is this equation is becoming? This is becoming equation of what is on the x2 y axis? X2. So is it in becoming x square plus y square is equal to r square? What is the equation of this? This equation is known as
Circle.
circle,
Equation for
right?
circle.
Right. So we just mentioned, okay. So this is equation whose circle is what? Sorry, this is the equation of a circle whose radius is what? 1. Right? Whose radius is what? 1. So can't this be a decision boundary? A circle with the radius of 1. This will be your equation of decision boundary that you are seeing right now. Okay, and these things will actually come to view automatically with your practice. Okay, this is not able to achieve with a straight line, then I have to do something else. It is not able to achieve this, I have to do something else, and this will come with the practice. But no universal law. Okay, I will do this thing only, it will work. Okay, you have to do a lot of practice, and trust me, machine learning, if you say somebody say that can be learned and I will become master in 1.5 months or 2 months, no, it's impossible. If you see anybody's course of machine learning, especially the good one I'm talking about, like your triple IT Bangalore one, if you are great learning, okay, one is great learning, But we are randomly picking it. We are randomly picking it, not randomly. Actually, we are intentionally making them zero. Okay. I think Varun, we have missed last two classes. In that, what happens? This thing actually will be picked by my machine learning model automatically. We don't have to choose this theta one and theta two. Okay. My machine learning model will choose these thetas, theta naught, theta one, theta two, and theta three and theta four in such a manner which minimizes your error. Okay, and what kind of error is this? Classification error. Okay, or which improves your accuracy. So automatically your machine learning model will adjust this. Okay, will adjust your weights theta naught, theta one, theta two, theta three, theta four, such that you get correct classification. So until you get correct classification, they will keep changing this theta one, theta two. When they achieve the correct classification, they will understand, okay, wow, theta naught should be -1, theta one should be 0, theta two should be 0, theta three should be 1, theta four should be 1. Got it, Varun? So it will automatically optimize this. We will change the value of thetas until we get the correct classification. We want to reduce the error, right? This is the one. It works. Manually, we don't have to do that. Automatically, it will happen. Okay. Now let me quickly come to the implementation part. Within 5 minutes, we can do the implementation using logistic regression. Barely 5 minutes, not more than. Okay, I have not opened Jupyter. Let me just open. I told you building machine learning model is very easy, but learning math behind it, how it works, okay? And your EDA part, the more time you can devote, more better machine learning models you can make. Much better machine learning models you can make. Let me show you simple example so that you can understand. For example, I just passed my LinkedIn. Okay, come on, LinkedIn. Oh, not on this. It will not be on this. Just link, right? Okay, and if I go to my own profile, contact info, GitHub. Okay, an example, let me show you some projects. Okay, small project. These are the projects that I created when I started building my machine learning model. Okay, although I keep updating them when I get the time, once in a 6 months or 7 months. So this was starting when I started learning machine learning. That time I created some example. Let me pick anyone. Suppose heart disease prediction. Okay, so see everything. For every thing I did, I mentioned a comment. Okay, what I am doing, what are the findings which are available, right? Every finding, whatever we are achievable. Okay, everything. See how many missing values there. I made a comment of the same. Okay, now let's deal with the missing values. Okay, we have mentioned if these would have been large number, would have improved median mode. As these are very less number, we can drop them. So with every comment I mentioned this. Okay, it was when I was just a beginner. Okay, everything, what is the finding, what I am finding relationship. Okay, everything, every sort of analysis, univariate, bivariate analysis, every sort of analysis, what is the finding of the same. Okay, with every proper, what is the finding of every particular visual, what it is giving. Okay, see, I just mentioned after I plot this count plot, and that's what is the finding of this plot in every visual I mentioned. Right, see everywhere. Okay, and then use different machine learning model at a one go. Okay, so several models and choose the best one, which is the best ever is the best one. And then one model is constructed, right? So maximum time, actually, as I told you, repeat again and again, you should spend on EDA. And trust me, these projects I've completed in 30 projects, I think in a span of 15 to 20 days only. Within 15 to 20 days, it was a deadline where I was learning. Within 15 days, you will submit all your projects. Okay, I was working at the same time from 9 to 5. There was no excuse at all. You will not receive certificate if you didn't produce your work. Okay, no excuse was there. 9 to 5 I was working. I have a family as well. Beside than that, I had to work that. Okay, so not me, or there were close to more than 100 participants were there in the same batch. Everyone did that. Everyone did the same task. Okay, so always never make an excuse just for those people who make the excuse that I don't have a time. Okay, if you want to learn, nothing can stop you. If you don't want to learn, then nothing is there. Okay, so maximum time. See, machine learning model is very simple. Creating machine learning model is damn easy. Main thing is that you should spend a decent amount of time. It will take time, at least 4 or 5 hours on the EDA. Minimum spend on that thing. Find out the findings. Then only you will be able to build the machine learning models. Okay. So let me come here and let me create a new file. And that's why I think 5 to 6 hours, or even if you include pandas as well, including pandas and NumPy and Seaborn, we have spent at least 8-9 hours on the same only, so that you can understand what this graph is doing, what this function will give us, what finding I will find out from this. That's why I expect you people to complete. Okay, so let me quickly mention import pandas as PD. Okay, import Seaborn as SNS. No, Seaborn is not required here. Even I'm not using that. sklearn. Done. Yeah, okay. Now let me quickly read it. df is equal to pd dot read underscore csv, and let me pick any data set because we have to check how it works. Barely 5 minutes work it is. df dot head. Okay, so we know that we want to drop this column. It's a name column. Name column doesn't make any sense in keeping, so we'll drop that. So df dot drop. What is the column name? Column name is name. Along axis is equal to 1 and in place is equal to true. Done. Let me check again. df dot head. Fine, it has gone. And let me check, is there any missing values? df dot is null dot sum. Okay, there is no missing value at all. Very good. We have to deal with this text column. So what I have to do, everyone? Tell me. This column should I drop or I have to keep it with it?
Hot encoding.
Yes, one hot encoding.
We have
For
to
the
keep it, sir, but we have to do.
yes. df is equal to pd dot get underscore dummies. And what we will pass over df and we'll mention drop. Automatically will pick first is equal to true. Done. And let me verify once again. df dot head. Done. So everything is numeric. Perfect. Everything is numeric. There is no problem at all. Now we need to split our data. So from sklearn dot model selection import train test split. Okay, and we know that it will give me 4 parameters. So x underscore train, x underscore test, y underscore train, underscore train, and y underscore test, right, equals to train test split. We have to pass. Okay, we have not separated yet x and y, so we should separate them. Very good. So x is equal to df dot drop, which is my output column in this case, everyone. Survived column, because we have seen, I'm doing all this because we have seen this thing multiple times. That's what I'm typing it fast. Okay, what is my output column in this case? Survived column, right? So in x, I want all the column except the survived column. So df dot drop survived column I don't want, along which axis is equal to 1, and I will not mention in place is equal to true. Okay, otherwise it will make impact in the original data frame for now because I need y yet. So df survived. Okay, done. And now I can pass here x comma y. Okay, test size equals to 0.2, random state anyone, suppose 42, and there is one more thing, stratify. Okay, is equal to based on which? Based on the y only. Fine. Done. So let me just check once again. X underscore train dot head. Fine. Everything goes good. X test dot head. Perfect. Everything is good. Now what I need to do, everyone? As also it's a distance based. Remember earlier what will happen? It will compute your theta naught plus theta 1x plus theta 2x. Okay, and so what we need to do? We need to do the scaling as well. Okay, for the scaling we have two options available: min max scaling or standard scaling. Okay, but if which is better if you talk about always people prefer your standard scale
Standard.
because it gives you a normal distribution. That is always better. So from which library we can pick it? That from sklearn dot pre-processing import standard scalar. Done. Create a class of the same as is equal to standard scalar. Done. And let me create apply fit and transform on the x train. Okay, and only transform on the test. So I'm going to mention x underscore train underscore s equals to s dot fit underscore transform, and which data? Only x train data, right? And only similarly x underscore test underscore s, we will do only transform s dot transform on the text data x underscore test. So far everything we have done the same. That's why some people may be thinking I'm typing fast. I'm doing this because everything what I'm mentioning we have done at least 3-4 times. 4 times. That's what I'm doing the same. Okay. Execute. Now it has been done. Now you can import your machine learning model. So from sklearn, okay, dot linear model import. This time I want to import logistic regression, right? This is my model. As simple as that. Doing is very, 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 very easy. Done. Come here. Okay. And we have to, it's a class, so I have to create an instance of the same. So instance is suppose model equals to logistic regression. Okay, and it has few hyperparameters. If you go here, this penalty thing that you are seeing here actually is corresponding to avoid the overfitting. There are three kind of regularization technique, basically we call them. It is used to prevent your overfitting. L2 regularization, L1 regularization, elastic net. This is a hyperparameter, right? And there is actually one important thing which is available. N jobs. Can you see everyone one thing? Number of jobs. Can you see here?
Yes, sir.
Right? What this purpose is, understand everyone. It tells you how many processors actually you want to use. How many processors you want to actually use for that purpose. Okay. Similarly, see there is an option you can specify. For example, I specify -1. -1 means use all the processors that are available in your system. None means what? It will use only one processor. Okay. None means what? Only it will use your only one processor. So when it will be training your machine learning model, it will be slow. If you want to make it faster, okay, you can mention n jobs is equal to -1. Example, n underscore jobs is equal to -1. Let me execute this. Done. Right? So for that purpose, it is used. Let me show you that. Come here and type n underscore jobs in logistic regression. Where it is, where it is, where it is. Come on. Let me come here directly, sklearn library, and go to. Come on, come on, come on. Can you see? Number of CPU cores used when parallelizing over the classes. Can you see everyone?
Yes, sir.
Right? So you want it to be run very, very fast. That means use n job is equal to -1. -1 means use all the processes. Okay. So what we have done here, I mentioned -1. So -1 means, come on, yeah, use all the processes. Okay. Other parameters are also important there. If we come here, which is good for you, is this fit intercept. Okay. This is your fifth intercept. You know what is the intercept? Intercept is this thing. We saw our line now. So what is our line? Suppose my line is this. So this is the intercept part. Okay. So you want this intercept part or not? Okay. If you mention it fit intercept is equal to false. So this intercept part, it will not take into the consideration. Okay. It will not take, but actually normally we take intercept. For example, we have an experience. Okay. And here we have a salary. Okay. So tell me everyone, this intercept is needed or not? With the experience, salary will be increased, guaranteed. Okay. This graph is looking fine, but this intercept is needed or not? Can we do this thing? Tell me, does a fresher have any experience? No, he's a fresher. That means experience is 0. Does he receive 0 salary? Even a person is
No.
unexperienced, he still receives some salary. still fresher is there and he will receive some salary. In that case, actually, your intercept is important. So at least you should analyze as per your scenario. In my scenario, intercept will be needed or not needed. For example, there is a scenario where it is guaranteed that when your input parameter will be 0, it has to be 0. In that case, you could mention fit intercept is equal to false. Getting the point, everyone? Right? You can mention fit intercept is equal to false. So it will not take intercept. But most of the scenarios, you will find that intercept should be true. So you should, as per your business domain or as per your requirement, you have to analyze whether I need an intercept or I don't need an intercept. Right? Similarly, if we come here, we have term known as maximum iteration here. Okay. See if I come directly here. Important terms I'm telling you, there can be anyone. Okay. See, max iteration by default is what? 100. Maximum number of iterations taken for solvers to converge. What do you mean by that? Okay. You're trying to ensure that your error is minimum. Okay. Or your error is 0. Okay. But how many iterations you want to do? Because what, suppose you choose some value of weights right now, and because of those weights, you get some error. It may be a classification error, it may be a regression error, doesn't matter. And what you do, you again update your weight to reduce that error. Again, you update your weights to reduce that error. Again, you update your weights to reduce error. So you are doing iteration, second iteration, third iteration, fourth iteration. So how many iterations, till how many iterations you want to try? That is your nothing but maximum number of iterations. Clear, everyone?
Yes, sir.
Right? This is your maximum. These are very, very important parameters that you should remember. Very, very important parameters, and basically important parameters that you should analyze when my model will convert. Otherwise, what will happen if suppose unaccidentally, I've seen the amateurs who saw, okay, I don't know this value, max iteration, let me increase the iteration. They put iteration to be 2000, and their model never converges. Keep running, 4 to 5 days happen, 6 days happen, 7 days happen. Because 1000 iterations are too much if you have a very huge amount of data. Okay, it will take huge amount of time. Even your RAM will crash, your system will crash. Okay, so you have to be a bit cautious. So let me just execute this for now. My model has been my object has been created. Let me train my model. So how do we train my model? By training, we use a method known as fit method. And how do we train? We always train on the training data. So x underscore train underscore s and the corresponding y train. From this only my model is going to learn y underscore train. Done. Okay, my model is getting trained. Yeah, it has been done perfectly. Now let's come and predict the values. Okay, let's come now and predict the values. So suppose I'm saying I want to predict the value of y test from the x test. So what I will mention, y pred is equal to model dot predict. Whose value we want to predict? Y values. From which? From x test. So I mention x test underscore s. Okay, the scaled value. Execute. Come here, check. And how do we check how my model is performing? Although let me just check what y pred I'm getting. Okay, 1010. From this we cannot make any conclusion. No issue. Let's import some matrices. Example from sklearn dot matrix import example accuracy score, or you can import confuse accuracy automatically filtering. Come on. Yeah. Let me import confusion matrix as well. Okay, execute, and let me come here. We can mention here example accuracy score, and it needs two value y true and y pred. Okay, y true and y pred. So what is true? True value is y underscore test, and the corresponding predicted value is y pred, receiving me 76.96% accuracy. Okay, and this is testing accuracy. Remember, this is your testing accuracy, not training accuracy. Similarly, I can check my confusion matrix if needed. If needed at all, you can check this, and it can be your again same value needed, y true and y pred. So y underscore test y pred. It will give you what? Sorry, I forgot to put a bracket here. Corresponding values here. Similarly, you want precision, recall. Then better than that, use what? What your classification report. So let me do one thing. It gives you everything. Classification report. Okay, it gives you everything. So I'm going to mention classification report. Again, it needs two arguments, y true and y pred. So y underscore test, y pred. Okay, result is scattered, no issue. Let me convert it proper. Let me put it inside the print statement. Okay, now it looks better. For every class, what is the precision, what is the recall, okay, and corresponding F1 score, everything you are seeing right now. Okay, this is the better. I told you when your precision and recall are better, especially when your data set is imbalanced. Okay, and in tomorrow class, I'll show you how to balance the data as well. Okay, and you will see when I will balance the data, my performance will increase. My performance will automatically increase when I will balance my data. Okay, means right now if we see here in if we come here, my data frame column name is I think survived column. Okay, dot value underscore counts. If you see, it is not balanced, right? Zero class has 545 data points. One class has 342 data points. Okay, so one class has less point, and accordingly you can check the values of the precision and recall. Precision is good, coming good for the zeroth class because it has more data points. One has less data points, so its performance not coming good on the one. Can you observe everyone? Please see. Right? See the difference. Even on the recall, it is good in predicting your zeroth class, but not good in predicting your one class. Even F1 score, which gives you the result about precision and recall both. It is good for the zeroth class, not that good for one class. So we will balance that. How will we do that? I will tell you how we can generate synthetic samples. Okay, this is the data set which is given to you. We will tomorrow see how can we generate our synthetic samples as per our requirement. We'll see that tomorrow. Okay, tomorrow very important things we will see our hyperparameter tuning. How can we do that? How can we generate our synthetic samplings? Okay, and before that, let me come to the thing that I require, very good thing that you will enjoy also. Come here. Okay, next thing is our ensemble learning or ensemble machine learning models. What do you mean by that? Understand everyone? Whenever the word ensemble is coming, first of all understand it means collection. Okay, and what happens in the collection? Understand everyone? So far we started with the knn algorithm, right? We use one knn algorithm to train my data. Perfect, done. Very good. I think then we discussed naive base. We trained our naive based machine learning model, done. Then I think we discussed decision tree. We trained this, done. Then we studied our linear regression, done. Then we studied our logistic regression. Okay, these 5 algorithms we have done. But what we see, every time we were using only one knn or only one naive base, or using only one decision tree, or using only one linear regression, or using only one logistic regression. This is what I was doing, only using only one estimator, or only using one machine learning model. Okay, but in ensemble learning, we don't use one machine learning model. That is the beauty. We use what? Remember, what is the mention? Collection. Okay, so we may use, instead of one knn, we may use 10 knn, 15 knn, 20 knn, 30 knn. Okay, similarly, any algorithm that you are working, naive based or decision tree or linear regression or logistic regression, so when you are applying your ensemble learning, okay, in that case, instead of using only one example logistic regression, you may use 10 logistic regression, you may use 100 logistic regression, you may use 1000 logistic regression. Okay, so in ensemble learning, one particular model only will alone will not be used. Same machine learning model will be used, but multiple models will be trained. Multiple. This one, this one. Example: if you are building our only using KNN, so we will use multiple KNNs. Or we are using only node base, so we will use multiple name base. If we are using decision tree, so instead of one decision tree, we will be using multiple decision trees. If we are using linear regression, then we will be using multiple linear regression. If we are using logistic regression, then we will be using multiple logistic regression. So collection of KNNs will be applied, or collection of naive base will be applied, or collection of decision tree will be applied, or collection of logistic regression will be applied, or collection of linear regression. Means whatever linear regression, logistic regression will be applied. That is what is nothing but your ensemble learning. Ensemble learning. This is what is all about. Okay. So instead of only using one model, or one base estimator. We will be using multiple base estimators. Okay, rather that is a better term. My core machine learning model will be known as base estimator. Okay, there will be a term known as base estimator. Okay, so we will be using multiple base estimators. There will be a parameter base estimator is equal to how many base estimator you want. Okay, so we will be using multiple base estimators. Okay, that if suppose it is knn, so multiple knn. If it is naive base, multiple naive base. If it is decision tree, multiple decision tree, and so on. Okay, and how it helps us understand what is the purpose of this ensemble learning. You will see that it basically used to improve the performance. They are basically used to improve the performance, but how they improve the performance? Let me come to that. Right, how it will come. So basically your ensemble learning or ensemble machine learning models have two tasks. Two kind of ensemble machine learning models are there. Okay, number one are known as tagging techniques. Okay, and second one is known as boosting techniques. Okay, so you can use two kind of ensemble techniques. One is bagging and second one is boosting, and purpose is different. Okay, when my model is overfitting, overfitting means it is performing very well on the training data but very bad on the test data. Means good overfitting. My model is what? Overfitting means what? Good on what? Training data, right? But bad on test data. I will say that my model is overfitting, or I will say that my model has high variance. Okay, my model has a high variance, and it normally happens when your model is complex model. Your model is a complex model. Remember, we saw yesterday polynomial regression. What was happening when my graph was like this? X1 and X2, something like this, X1 and Y, something like this, right? When my data points were like this. So when I use only first order degree polynomial, so my graph, my line was coming like this, right? When I increase the polynomials and read to the degree 3, remember it was coming like this. Exactly, it was learning my training data. Remember, Varun, if you attended the class yesterday, right? And what was happening? I
Yes.
was increasing the complexity. Earlier, I was having only term theta naught plus theta 1x, right? Plus theta 2 x2, something like that, theta 1 x1. Then I introduced theta 2 x1 square. Then I introduced theta 2, theta 3 x1 x1 cube, something like this. So I introduced higher degree polynomials. So my model is becoming what? More complex. So when more complex model will be there, 100% it is going to learn your training data. Right, 100% it is going to learn your training data. When it is going to learn your training data, of course, when if any machine learning model 100% learns your training data, understand 100% is going to do overfitting. Okay, so you will get overfitting when your model is complex. Okay, so having too complex model is also very dangerous. Okay, and when my model is complex, it will do overfitting. It will do very good performance on the training data because I learned that, but it will do bad performance on the test data. And when it is the case, we will call it as high variance. And to reduce this high variance or to reduce this overfitting, we will use which kind of technique? Bagging techniques. Okay, we will use bagging techniques to reduce the overfitting. Now come here, boosting. What is the purpose of the boosting? Understand, everyone? When my model is underfitting, right? Means what? My model is too simple. It is that simple that it is not able to perform bad on training data even. It is not learn even the training data a little bit. Bad on training, even bad on the test. Both performance are third class. Okay, bad on the training, bad on the test. Right? This is the case. When bad on the training, bad on the test, that means your machine learning model is not able to learn at all. Okay, and it happens when my model is too simple. Absolutely too simple. So what will happen? My model has a too simple. We'll say that my model has a high bias. Okay, when model is too simple, we'll call it as a high bias. Okay, when it is too complex, we'll call it as a high variance. Or we can say when my model is overfitting, we'll call it as a high variance model. When it is underfitting, we'll call it as a high bias model. Okay, so boosting techniques, why we use boosting techniques? We use to improve the performance. Here, performance is bad, right? Not even on training, not even the test. So we'll boost the performance. Okay, we will boost the performance here because my model is not performing good even on the training data, not even on the test data. Right? You can consider as like in a class, there is a student, right, who performs very well when internal happens, because internal normally happens in a college. Teacher gives the same questions whatever they teach in the class, right? He performs very well, and whenever semester exams come, he's gone. He's not that good performer, right? So tell me, which is this person? He's performing good on internals but not performing good on externals, where the any question become relevant.
Overfitting.
Yes, overfitting, right? That is overfitting. But there is a student who neither performs good even on the internals nor on the externals. Then who is that person, everyone? What is happening in this case?
Underfitting.
Underfit, right? So we have to do what? In this case, we have to boost the performance. And to boost the performance, which kind of algorithm we will use, everyone? Boosting algorithm, right? We'll do the boosting, use boosting algorithm. So boost two kind of requirement will be there. We'll decide what we need, bagging technique or boosting technique. If it is doing overfitting, we will use bagging technique. If it is doing underfitting, we will use boosting technique. So see, one thing is coming. When it is too simple, my model is too simple, very bad performance. When it is too complex, again, there is an issue, overfitting. Okay, so what should we do? Complex is dangerous, right? Simple is dangerous. So what we have to do? We have, my model has not to become too complex, neither to become too simple. So some intermediate we have to choose. Not make it too complex. If you make it too complex, it will do what? Overfit. If you make it too simple, what it will become? Underfit. So don't make it too complex. Don't make it too simple. This process is known as your bias variance trade-off. Bias variance trade-off, because what will happen if we will try to reduce the complexity to avoid the overfitting, my model will become what? High bias. Okay, if you try to increase the complexity, my model will have a high variance, right? So we have to make a trade-off between bias and variance, and this is the interview question. Do you know what is the bias variance trade-off and why it is required? Okay, so you have to make a trade-off between them such that we don't have a high bias, we don't have a high variance. We don't have a high bias and we don't have a high variance. That is nothing but a bias variance trade-off. Very common interview question. If machine learning you are giving, they will ask you, do you know what is the bias variance trade-offs and why we need it? Any doubt in this, everyone? Please tell me. If it is okay, just tell, I'll move ahead.
Sir, will whatever we have seen
Mm-hmm.
in boosting and bagging
Mm-hmm.
and overfitting and underfitting,
Mm-hmm.
so will these concepts only be applicable to supervised machine learning only, or will it be applicable to unsupervised as well?
Actually, unsupervised, normally we don't deal this. Enterprise and unsupervised, I have never seen that actually. I've never seen that in unsupervised learning algorithm. We have such kind of thing available because, but I will check it because I've never seen that kind of problem because under your, that problems are already different. Actually, unsupervised, and remember in unsupervised, we don't have a class available. Getting the point? We don't have a class available. What is our
That's
actual
why I'm
output?
asking,
Yeah,
sir,
yeah,
because
got it the point.
we don't know what is our actual output. So how do
Actual
we
output.
get
Yes, yes, yes.
overfitting
Get it.
or
Because
underfitting?
I have not seen such kind of things in even in unsupervised learning. I've never saw that even. That's what I'm saying. I never saw that because we don't have a even output. We can know what is my actual output is there. Okay, we never know what is my. We have to predict the trend. Okay, the trend or a pattern among the data. Okay, we don't have know the pattern among the data. In that, I've never see even anywhere it is available or not. Let me check. Yeah, that's a good, interesting question, but I don't think so. It should be possible, but let me check because I've never saw that even. Very good question, but let me check. Ensemble learning for example, K means is actually your machine learning algorithm. Let's see. No, 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 no. Ensemble. The different approaches there actually. Directly, no, the approach that we are discussing now, we don't have that approach here. Can you see here? It's mentioned here also. Somewhere. See, on the other hand, in the supervised unsupervised problems, we do not hear about a lot of ensemble technique. It's possible to use this technique on the question. It's only not only possible, but a lot of strategies have been developed over the years. Similarity matrix, a different approach is there actually for the same. Similarity matrix is there. Okay, and one more approach is there. Different approaches. They are not the same approach. Okay, this is one a different one, graph connected one. Okay, directly those methods are not applicable. I think. Let me check. I don't think so. It should be there because how will they'll come to know? Hmm. There may be some research issues. Let me check. Come on, come on. Clustering ensemble method. People are doing research. Yes. See, in 2019, there is a paper established. But certainly these methods, I don't think so. There is available. The same similarity measures they are using. They have a different approach. It is there, but it's a different approach. But it's a good point to discuss. Yeah, it's very, very good. There's a different process altogether. What they're doing, ensemble member generation. And they've used a matrix that are even different in that case, actually. Okay, so there are different approach. Yes, it can be applied in that also, but they have a different approach. Directly, actually, this kind of thing is not possible there. And we can understand that is practically understood why it is not possible. Okay, because how will we come to know how my model is performing? Okay, so approach is different for the same
Right,
purpose.
sir.
Approach is different. Directly, we will, until we don't know the output, how can we say my performance is good or bad? That is the main issue. Okay, so in unsupervised, it is a different approach altogether. That's why people normally talk about supervised only. Okay, but let's come ahead. Okay, so what I was talking about, your this. Okay, come here and let's come to first of all bagging technique. What the bagging techniques are? Understand first of all, bagging means it's a short form of bootstrap aggregation. Bootstrap aggregation. What it does, understand everyone. Suppose in my data model, okay, I have 10 data points. Data point 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, I have 10 data points in my data point. Okay, in my training data, suppose example. In my training set, I have 10 data points. So what I will do, suppose I will decide, as is the ensemble learning, so multiple machine learning models will be used. So suppose I decided I will use 3 machine learning models, M1, M2, M3, right? And this M1, M2, M3, suppose I'm taking example, anyone, suppose KNN, KNN, KNN. They have to be same, KNN, KNN, KNN. Okay, and or decision tree, and anything you can pick. Suppose KNN, 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 I pick. Okay, the multiple machine learning models I'm picking, all are KNN. Then what I did, I will pass here 10 data points. How many data points are there? 10. But I will pass them here. What? Understand everything. That is important catch here. By sampling with replacement. With replacement. How? I will pick a random data point from this. One random data point from this. Suppose the data point is 2. Okay. I will put it back again. I will pick one more data point, maybe 3. Put it back. One more data point randomly. Suppose it is 2. Because randomly we are picking now. So we may get any data point. We never know. Right? Any data point we may get. Again, put it back. Next data point, suppose 10. Put it back. Next data point, suppose again 10 came. Because random we are doing sampling with the replacement we are doing, right? This way we will collect 10 data points. It may be anything. Suppose again 2 came. Maybe 3 came. Maybe 5 came. 1, 2, 3, 4, 5, 6, 7, 8. And let me pick once again. Suppose again 3 games. Again, this time 7 games. Okay. Now these 10 data points means we'll take that many samples, that many data points are there, and we'll pass it to the my first machine learning model. Right. Again, now what we will do, same kind of input we will prepare for M2. Any one random data point will be picked. Maybe it may be anything. Suppose 1 is picked. Come here. 1. Put it back. Second, again, suppose 1 came. It can come anything. Means you have to pick 10 data points randomly with replacement. So it may be any possible combination 2. It may be again 10. It may be 3. It may be 3, 4. It may be anything, but 10 data points. So these 10 data points will be passed here to them. Again, entire data points are available. One random data point will be picked. Suppose 5 is there. Put it back. Again picked. Suppose 4. Again put it back. Again pick. Suppose 4 came again. You never know because it is sampling with a replacement, right? You're putting it back, taking it again. Putting it back, taking it again, right? So it may come again and again. So this way you will again obtain that data point. It may be 10 again next. It may be again 3 or something like that. 10 data points you are passing here. Okay. So on which data my M1 is getting trained, on which data M2 is getting trained, on which data M3 is getting trained, you don't know because randomly any data points may come here. Okay, so it may be learned differently, it may learn differently, it may learn differently. Everyone is learning differently, right? Now this machine learning model will be trained. So on this data point, your machine learning will be trained. So we have 10 data points. So 10 data points M1 trained, 10 data points M2 trained, 10 data points M3 trained, but it is not guaranteed they will be trained on the same data point that M1, M2, M3. Not guaranteed. Right? Randomly, we have given the data points to M1, randomly to the M2, randomly to the M3. Similarly, we have 1,000 data points. So 1,000 will be given to M1, 1,000 will be given to M2, 1,000 will be given to M3. But how they will be prepared means what kind of data will be given, that is sampling with replacement, right? Then what will happen? Suppose it's a classification problem. So its output will be combined to what example we are saying, let's say to a voting. If you are classification voting. Now see what happened. It has been trained perfectly. Your model has been trained. Now you have a data point, test data point. You give a test data. So that test data point will be given to machine learning model 1. It will be given to machine learning model 2. It will be given to machine learning model 3. So your machine learning model 1 will give the prediction. I pass one test point, suppose x1 and x2. I pass it to all three. This, and this. So M1 will predict something. Suppose it is saying it is class A. Okay. M2 is saying it is class A. M3 is saying class B. So we will take voting. Tell me, voting means we are asking from the multiple people, right? Tell me, what do you think? What do you think? What do you think? Remember, for example, you want to purchase a car. So before purchasing a car, what do? You ask from several people. Okay. And you take the opinion whosoever says maximum. Okay. 70% people are saying buy this car. You purchase that car only. This is what voting is. You take the voting from every machine learning model, right? This one, this one, this one. So two are saying A, one is saying B. So who has the maximum vote? A. So you will say that. What is the class, everyone? Class is A, of which this data point. Clear? Please tell me.
Yes, sir.
Clear? Simple voting. But now suppose it's a regression problem. Again, it's a regression. If instead of voting, it's a regression problem, then what you will do? Again, same thing will be there. Training data will be given to M1. Training data will be given to M2. Training data will be given to M3. This time it's a regression problem. Suppose it is giving me a test point is given. Test point is given to M1. Test point is given to M2. Test point is given to M3. So suppose M1 is giving 4.5. M2 is giving 5.7. It is giving 4.3. So what you will do in case of regression, instead of voting, you will use here mean. So average of these three will be taken. Means what? 4.5 plus 5.7 plus 4.3 divided by 3. This will be your output file of regression problem. Clear, everyone?
Yes, sir. It's pretty much like what we did with KNN when we learned KNN, classification and regression.
In the last stage, you can see. In the last stage, this was the thing. But this stage is different
Yes,
entirely
sir.
together. This is different. Bootstrap. Right or wrong? This is the core.
Right, sir.
How it is preventing the overfitting. We are saying, okay, you learn independently. You learn independently. You are learning independently. In the later stage, we'll take your opinion, so that you are not having any kind of biasness available with you. You learn independently, you learn independently, you learn independently, right? So no chance of overfitting, right, everyone? Clear?
Yes, sir.
This is the concept of bootstrap aggregation. Remember, and very famous your bagging algorithm is a random forest. Very, very famous algorithm is known as random forest algorithm. Okay. Remember what is the name? Forest. In forest, what do you have, everyone? What is a forest? What is the definition of the forest? We have lots of
Group of
trees.
trees.
Trees, right? So in random forest, your algorithm that we're talking M1, M2, M3 is fixed. That is always decision tree. Okay, so random forest is a bagging tree where your underlying machine learning model is what? Which model, everyone? Underlying it is having only and only a decision tree. Here, very famous algorithm, random forest, which have underlying algorithm, which is getting trained, is nothing but decision tree. Fixed is there. In other, we can change. I'll show you that. In a bagging classifier, if I use, I can change my machine learning model. I can put KNN there. I can choose what can be M1, what can be what can be M1, M2, M3. Are they KNN? Or what can be M1, M2, M3? Are they linear regression? Or are they naive based? Or are they logistic regression? I can pick. Or are they decision tree in bagging classifier? Especially there's one. If you talk about random forest, it is fixed. M1 will be decision tree. M means all the algorithm will be decision tree only. Okay, remember what's important? Every algorithm has to be the same. That is the only thing. Remember, every algorithm has to be the same. If decision tree, all decision tree of all KNN, all KNN. If all naive based, all naive based. Remember that, everyone. In random forest, it is always fixed. What is that? Decision tree. Okay.
Decision tree.
Now come to next algorithm, your boosting technique, how it works. Okay. In boosting algorithm. So what it does, remember, it's a sequential technique to improve the performance. It is a sequential technique. Sequential technique to boost the performance. Okay. Sequential technique to boost the performance, right? In this earlier ways, all the machine learning models are trained in parallel, right? This one, this one, this one, all trained in parallel, but it is not the case here. Okay. Suppose first machine learning model is there, M1. Okay. And you have 10 data points. So it will be trained on all 10 data points. Trained it, done. Okay. It gives some performance. Okay. It gives some performance. For some data points, it gives me correct result. And for some data points, it gives me wrong result. Okay. So what we will do, now we will use second machine learning algorithm. And this machine learning model will try to rectify the mistakes done by M1. Okay, the second machine learning algorithm will try to rectify the mistakes done by M2. Just a second, let me connect it. My headset is just charging. Come on, come on, come on. Where should I connect? Yeah, I'm back. Okay, so am I audible, everyone? Hello?
Yes, sir.
Okay, okay. See, so
Audible, audible.
what I was saying, so M1 will do some predictions. Okay, suppose there are 10 data points. So for the 3 data points, suppose data points are A, B, C, or 1, 2, 3, let it be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So out of these 10 data points, for 3 data points like 3, 5, and 7, it give me wrong result for these data points. Okay, rest it is fine. So these mistakes will be corrected by which model? M2 model. So again, all 10 data points will be passed here. All 10 data points will be passed here. But now, how they will be passed? Every data point will be assigned some weights. Will be assigned some weight. Okay, so first M1 has done, then we'll go to the M2. In M2, all the data points will be passed. But understand, this information will also be passed. Which data points have done the mistakes? Which I have done 3, 5, and 6. So now when I'm passing from M1 to M2, all same data points will be passed to M2 this time, but directly they will be passing by using some weights. So some weights will be assigned. Okay, some weights will be assigned. So those which have done the wrong, means you have done the correct classification, they will be assigned smaller weights. Like smaller weight for this, smaller weight for this, smaller weight for this, smaller weight for this, smaller weightage for this, smaller weightage for this, smaller weightage for this. Okay, and those points whose machine learning model failed to predict, means who are giving them the wrong classification like 3, 4, and 5, they will be assigned higher weights. Higher, higher, higher. Means what? To tell, okay, everything is fine. You have to focus on 3, 5, and 7. We don't have to focus this on this. Right? You have to focus on this. You don't have to assign. For example, in our class, there are several students. Some one are those who are very good. They always get pass. And there are few who always get fail. Right? So what do you do? Okay, your teacher says, pay special attention on these. These are the weak students. Okay, so what you will do whenever you're teaching in the class, you will stay focused. Okay, are you learning? You will ask from those people actually, especially who you think, okay, we may fail. We want to improve our result, right? So what you will do? You will pay special focus on the weak links, your weak students. The same thing is doing what we are assigning higher weights to those which have done the wrong, which for which my machine learning model predicted wrong. 3, 5, and 6. So higher weights will be assigned to them, so that machine learning model has understood, okay, I have to focus on correcting these wrong results, right? So of course, my performance will be improved somehow, result obtained. But now, again, it gave me some mistake. Okay, so out of the 3, it corrected. So now I'm getting, suppose, only 1 wrong result. Earlier, it was giving 3 wrong results. Now, finally, we are getting only 1 wrong result. M2 corrected something. So mistake done by the M1 has rectified by the M2. Now, what will happen? Still, we are not getting the correct result. Make it M3 example. Again, all data points will be fast. Now, what will happen, everyone? You can understand, everyone. Whichever results M2 has predicted wrong, those will be assigned again higher weights. And those who are
Yeah,
correct, right? Those who are correct classification, they will be assigned lower weight. And this is how your boosting algorithm works. So they are working in what? Sequential manner. First M1 trained, then M2 trained, and then M3 trained. So it is a sequential process. Clear, everyone? Any doubt in this? Please tell me. Even single.
sir, a doubt I have.
Mm-hmm.
Sir, now we are assigning weights to. If my data point is performing bad, then we are assigning it a higher weight, and if good, then
Actually,
smaller weight, right?
remember, yes, 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 yes. If it is
Okay.
performing bad, we
So
will assign them whichever data points are giving me wrong results. For them, we will assign them higher weights.
okay. So and with weights, like we are multiplying the value of data point with weight, and then we are sending to M2.
You can
Is
call
it
it.
so?
You can call it. You can weights can be assigned any manner. It can be anything. We can make them scale by much. Weights means how you are providing the weightage. Okay, so we are just telling more weightage should be assigned to this particular algorithm. More weightage should be assigned to this
Okay.
particular algorithm. That is the only thing. This particular data point should be assigned
Okay.
more weight. This particular data point should be assigned more weight. This particular data point should be assigned more weight. For example, take it this way. We can take it that way. Suppose there is a column known as salary. Okay, there is a column known as age. Okay, and there is a column known as suppose height. Here I mentioned 5,000. Okay, here I mentioned 30. Here I mentioned 1.5. So which has the more weight here, everyone? So always
Salary.
your machine learning model will be always make decision on the basis of what? The one which is having the highest
Salary.
numeric
Yes.
value. Okay, this is one way of considering the weight as well. Getting the point? Okay, so
So
anything.
if we are assigning the weight, sir,
Mhm.
so will it be will this algorithm become reinforcement learning, because we are assigning weights, but there is no feedback here,
But remember, in reinforcement learning, what happened? We don't have the predefined output as well. Getting the point?
right?
We don't have
Yes,
predefined.
sir.
We learn by our own self. We go to the market, do the mistake, and learn ourselves. Okay, this is a mistake. Now I will receive a positive feedback. Yeah, partially you can say this way. In that also we receive rewards. You can say that in there we receive rewards, positive or negative reward. So say little bit same sort of effort is happening here. Little bit same sort. But reinforcement learning in the beginning stage we don't have any input available. We just go to the market, do the mistake, and then we learn. Getting the point? So you,
Yes, sir. And
uh,
then there was a feedback or something like that
yeah,
in
yeah,
that.
rewards for there, positive reward or negative reward. If you are doing correct, you will get a positive reward. Okay, if you are doing mistake, you will get a negative reward. Almost say that
Negative
thing.
reward, right?
That thing you can say is can be analogy with that. But other than that, in reinforcement learning at the beginning stage when we start our training phase or something like when we leave an amateur or leave a novice winner. For example, our self-driven car, it directly goes to the road, okay, and it takes an action automatically. I don't know what he has had to do. Right, in the beginning it is not known here, but here in the supervised learning our predefined outputs are already with us. Right, means there's someone to supervise you. That is the basic. But and
Yes, sir.
one analogy you have predicted very nicely. Means here there also we get some rewards, positive or negative. Here we do that with the help of weights. Right? Here do we that with the help of weights only. I think should be okay.
Yes, sir. Clear, clear.
Yeah. Any doubt, anyone? Right? And now let me do one implementation quickly. Okay. So where it is, where it is. Okay. Let me come here. And we already have a training data, X-train and very good. So let me do one thing. I'm saying that from sklearn dot ensemble. Okay. Import bagging classifier and bagging regressor. Can you see both things are available? You want to use regression problem, then use bagging regressor. You want classification problem, use bagging classifier. Your choice. Execute that. Again, it's a class. So I have to create an instance of the same. So I'm saying model 1 equals to bagging classifier, right? Okay. And here actually is a parameter known as base estimator. Can you see everyone? Please see. A number of
Yes, sir.
estimators. Two things are there. How many estimators you want and base estimator. It will work. If you don't specify a base estimator here, the default it is going to take is a decision tree. Understand that. The default base estimator here is default base estimator is what is decision tree. If I don't specify, it will work, no problem. Okay, and how many base estimator it will take? By default 10, which you can change as per your requirement. So let me execute this, no problem. Done. Okay, and let me come here. Model is done. Let me fit model 1 dot fit. Okay, on our x underscore train underscore s. Okay, and my y train. My model has been trained. Awesome. Let me predict y pred 1 equals to model 1 dot predict. Okay, and we will pass our x underscore test underscore s here to predict my corresponding y value. Done. And we can use our accuracy score example. Accuracy score of y underscore test means y true and y pred. Y pred 1. Okay, so how much accuracy I'm getting, everyone? 74.71. What is that? Decision tree. By default, it is used a decision tree, but I can change it, right? So by default, it has used decision tree. Okay, so let me again copy this. And I'm making it this time, or let me do one thing to save the time. This one, shift 1, control C, control V. Yeah, model 2. Okay, and here I'm mentioning my base estimator equals to, okay, whatever model you have used. Example, let me do one thing. Quickly come here. Let me see from, or let I imported logistic regression already. Let me use that only. Okay, so I'm gonna say suppose model 3 equals to logistic regression. I'm using this model, right? Execute, and in this I can mention model 3. Okay, I'm using base estimator. What? Which model base estimator I'm using, everyone? Logistic regression. Fine.
Logistic regression.
Okay, and make it model 3. No, model 4. It is better because you use that term for the same model 4. Execute. Done. And model 4 dot fit. Okay, and now come your model 4 dot predict. Okay, and your accuracy score y pred 1. Fine, no issue. Everything is good. Okay, it's 77.52. Can you see, everyone?
Yes, sir.
Right? Any doubt in this? And you can do one thing that's very good thing that you can check. This is our model that we use for the same accuracy score was testing accuracy was this one. And let me do one thing here. What is my model name? Let me predict y train predicted. Y train p equals to, this model name is, I think, model dot predict. Yeah, model is fine. Model dot predict. I want to check actually training accuracy as well. Okay. X underscore train underscore s. Okay. And let me also use accuracy score and pass this time y underscore train is my true value, and corresponding predicted value is y train p. Okay. Execute. So 80.53 is my training accuracy and 76.96 my testing accuracy, right? And let me come here in my this model. Let me also check the training accuracy. Okay, so I'm going to say y train p1 equals to model 4 dot predict. Okay, and I'm passing my x train underscore s. Okay, and calculate the accuracy score. And here let me pass y train and y train p1. Okay, execute this. 79.7, and see the difference between these two, everyone. This is 77.5, this is 79.83. Okay, these are closer in comparison to the earlier logistic regression that we used. See, the difference is little bit higher on the higher side. Can you see everyone?
Yes, sir.
Right, this is better. So this is what it's doing, it is preventing overfitting. Okay, this was the purpose, it is preventing overfitting. So any machine learning model you want to fit in inside, you have to mention here base estimate. It will work. Similarly, directly we have a available known as random forest from sklearn dot ensemble import random forest classifier there, random forest regressor is there. Anyone you can use. Okay, create model. What is the model number for? Okay, so model 5 equals to random forest classifier. And if you go here, everyone, you will not see an option of base estimator. Can you see? Only thing is available is number of estimators. We don't have base estimator available here because default is what? Decision tree, right or wrong? The default is decision tree. It will remain decision tree only. You cannot change in the random forest classifier. It will remain the decision tree here. So we can say the base estimator here is always, and you're it is very much, decision tree is very much prone to overfitting. That's why it has been designed. Base estimator always is which? Decision tree. Always. You cannot change that. You don't have a power. You can change the number of estimators. That is fine. Okay. So let me execute this. Find no issue and move it upside. Okay. And we can fit very quickly. Model 5 dot fit x underscore train underscore s and y underscore train. My model has been trained on the training data. Let me predict training accuracy and the testing accuracy. So training accuracy, I'm saying y train rp for random forest equals to model 5 dot predict of x underscore train underscore s. Okay, and similarly, let me predict y test rf equals to model 5 dot predict and x underscore test underscore s. Done. Let me compare the accuracy score. Here you have to pass a true value. True value is y underscore train, and predicted value is y train rf. Okay, execute. Done. 98.84. Okay, fine. Let me come here. Testing accuracy. Let me check. Mm, y accuracy score again, and this time let me pass same. What is the true value? True value is y underscore test, and predicted value is y test rf. Just ensure that everything is fine. Yeah, random 5, model 5.fit, train RF, we predicted the training value, corresponding training accuracy. Then we predict corresponding test value and the corresponding test accuracy. Okay, fine, execute. Okay, still a huge difference is there, 76.40 and it is that. Okay, already there, but we can change the hyperparameter and try to do that. What is the base estimator? 100. Let me make it 300. Let's see what is the effect. 200. Okay, we again execute this, 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 again execute this. It is even reducing. Okay, no problem. But you can change the parameter. You can check. Where everyone?
Sir, I'm still having few doubts, but
Tell
is it
me.
okay to ask those doubts because it's pretty late? So
No issue, no issue.
if
Let
it's
me.
getting late, then I can write
No, no,
down
no.
loud,
Ask,
write
ask,
down them and ask.
ask me. Ask me. No problem.
Okay.
Ask me. Yeah.